Hey guys, Brian here with an update on blockcillin, the HTML5 game I've been working on this year. Recently I started rewriting the whole thing in Dart, and to be honest it's been a little brutal just because I'm starting from scratch. However, with this update I made a lot of progress, and so I'm getting excited about the project again. The first thing you'll notice is instead of the old HTML elements I was using for the menu buttons, they're now properly rounded. They also change color when you move your mouse over them, and the main thing that was hard to replicate with Dart was making them fade out and fade in properly. But with the help of CSS3 transitions, I was able to replicate the fading in and the fading out. And also I used the onTransitionEnd event, the stream event offered by Dart, to detect when the fading out animation was complete so that I could pluck those unnecessary DOM elements from the DOM. It's not necessary, I guess, to go that far and remove the main menu from the DOM if it's not shown, but it's probably more efficient, and it just feels like the right thing to do. The next thing I changed is now I'm rendering the entire board with all the cubes and rendering multiple rings of cubes rather than just the 4 red ones that I had previously in the previous update. And these cubes are all rendered into a single vertex buffer object. In the JavaScript version I had one cube vertex buffer object that was repeatedly translated and rendered with many draw calls. But right now I just have a single vertex buffer object containing all the cubes and the rings. And actually calculating all the points for these wasn't very difficult at all, because I finally learned some basic math like vectors and quaternions to make it easy. I simply used one vector, swung it left, swung it right to create the pie shape, one slice, and then I used the quaternion to translate that pie slice around the axis to create a ring. Then I used the translation vector to move the code down one notch, draw another ring, and repeatedly did that to get the whole board. Before I was using, in the JavaScript version, just the point to calculate cosine and sine, to calculate each of the points on the circle, and then hard-coded those. Yeah, it was pretty ugly. But thanks to Math for Game developers and also the open source Vector Math Dart library, I was able to reverse engineer and figure out how I could use those quaternions and vectors in real world code. So, thanks guys. The next thing was, you can also see 2 graphical effects here. The inside of the cylinder is now shaded properly, and that was from adding some simple lighting. I poached the code from MDN's WebGL lighting article. There wasn't too much difficulty with that. One problem I had was I wasn't rotating the normals with the board as the board was being rotated. So the shadows were moving, things are flickering from complete darkness to color. But once obviously I fixed that problem and rotated the normals with the board, everything rendered properly and it started looking good. The final effect you can see here is that if you look at the bottom of the board, it fades into black. I'm trying to create the effect of the pieces coming out from the bottom, and I tried this in the previous JavaScript version of blockcillin, but the code ended up just making it look like a linear gradient was pasted over the entire screen. And that was because I had put that fading out, the fade to black code, into the fragment shader. This time I was a little bit smarter, and I moved that to the vertex shader to take account of each vertice's point in space. So now it looks like all the blocks are fading properly around the cylinder and into the darkness. So that's about it for this update. For the next one, what I'm going to try to do is when you create a new game, instead of the board just appearing suddenly in your face, I want to actually make it so that the blocks kind of fall from the sky and fall into the initial board position. And then when you pause the game, I like those pieces to kind of break apart into your face. And when you unpause, I want them to fall back into place again. I think it's a cool effect that'll give a lot of personality and increase the wow factor of the game. But I think it's also useful to see whether I can manipulate selected points in that one large vertex buffer object and see whether that's actually practical, or whether or not I'll have to go back to the technique of doing multiple draw calls, each on each cube's mesh individually. So I think that'll be a good test of the current code base and seeing how far we can go with the current strategy. Alright, well, see you then.